Hey guys, I think I might have figured out some kinks in my little tablet, so hopefully this video goes as planned. We'll see. Okay, our target is to be able to reflect a figure in a coordinate plane. Big picture, I want you to be able to do this in a coordinate plane, but I'm so proud of you if you can figure it out with just the figures to see if they're a reflection. Okay, so let's go ahead and get started. Go ahead and title this reflection. And our essential question is, what does a reflection change and not change about a figure? There's constants that must be the same, otherwise it's not a reflection. And there's things that have to happen in order to be considered a reflection. First of all, here's your two definitions right here. Okay, a reflection is a flip. So this picture right here is to help you visualize what a flip is. Okay, line of reflection, you flip. This line of reflection, okay, you have to have a line of reflection. It's the line at which the figure flips over. So if this was a piece of paper, we would fold here, okay, this red figure would line up with this blue figure after we folded it, and we could like see through the paper to see that they matched, okay? Mathematically, here's your big picture I want you to focus on is here's what happens on your coordinate grid, okay? Remember, I taught you what symbols represent images, okay? So the red figure right here is the original figure, okay? Then it gets flipped across the x-axis right here. Let me go ahead and write that down. I don't want that page. Try again. Oh, my little program's freezing on me. Ooh, there it goes. So it flips across. Remember, this is your x-axis, okay? So we fold on the x-axis right here, and our new points are on the quadrant. This is quadrant 1, quadrant 2, and quadrant 3, okay? Essentially, here's what happens mathematically. All the y's became negative. When we go from quadrant 2 into quadrant 3, all of those y's became negative, okay? Now, back to the original figure, when we flip in the y-axis, okay, we flip in the y-axis here, we fold on the y, these two would line up, we would look at our paper and see that they line up, and essentially here's what happens. All your x's go from positives to negatives. You flip the sign, okay, flip the sign of the y's or flip the signs of the x's, depending on which axis you're turning it. Sorry, not turning it. It's not a turn. It's a flip. All right. So let's go ahead and start off with ones that I'm so proud of you if you can do. Okay, but they're basic. All right. Tell whether the blue figure is a reflection of the red figure. Okay. Our first one, the blue figure of a reflection of, if we were to flip this one, the top would become the bottom and the bottom would become the top. Is that what happened? So no, because, oh, it still has that kink, rats, because it translated. This just moved. No, because, sorry, it's being slow at picking my pen. Because it is a translation. Okay, the second one. Is the second one a reflection? No. It is also a translation. So no, it is a translation. All right. Figure 3. Our bottom would become our top if we flipped it over this line. Okay. And our top would become our bottom. This one's a yes. Because If we fold on that line, they'll match up because our bottom will become our top and our top will become our bottom. They're the same shape, same size, flipped, turned, not turned at all, flipped. I'm going to go ahead and pause my video and see if I can't get my tablet working again. So I apologize if it's a little wonky right now. All right, now let's go ahead and move on to some at grade level material. This is something I know you guys can do just by looking, okay, at grade level. So we're, of course, looking at a coordinate grid, okay. The vertices of a rectangle are A is -4, -3. B is -4, -1. C is -1, -1. And D is -1, -3. Draw the figure and its reflection in the x-axis. So let me go ahead and write down our points. A, B, C, D. Okay, and I'm going to show you what it looks like in the reflection. -4, 3. -4, 1. -1. -1. -1. -1. -3. Okay, so let's go ahead and put that on our coordinate grid. Remember, here's how you graph. -4, left 4, up 3. Up 3. Oh, I don't know what happened there. -4, up 3. Okay, this is A. Got to label it A. B, -4, up 1. Label it B. C, -1, -1. Rewind. All of these are negative. That's why it doesn't make sense right now. Let me go through and fix all of that. That's negative. Okay, try again. All right. -4, -3. Some of you probably already caught that. -4, -1. There we go, down 1. -1, -1. -1, -3. Okay, I should have labeled these A, B, C, and D. All right. Man, I even have a tablet and I'm not doing good. Rats. Okay. Now, we're going to reflect it across the x-axis. Right here is your x, remember? So we're flipping it across. So our B's and C's will be on top, and our A's and D's will be on bottom. Roughly, they're going to be right here. I'm flipping it, so they're still going to be the same distance away from the x-axis. So, this is now B image. This is now C image. D is still going to be 2 away from C. This is D image. This is A image. And there you go. Mathematically, here's what happens. When you reflect in the x-axis, your x's will stay the same, but your y's will flip signs. So A image should be at -4, flip y, +3. And that's what I should have here. Good, I do. B image should be at -4, flip the sign of y, +1. C should be at -1, -1, flip the sign, and this one will be +1. D image should be at, keep x the same, and flip the sign of y, +3. All right, 4, B. Now we're going to flip the original figure, this one, the black one, in the y-axis. Here's what we should be getting when we flip in our y-axis. So, one second. Okay, I'm going to rewrite it. A, B, C, D, -4, -3, -4, -1, -1, -1, -1, -3. Okay, mathematically, when we flip in the y-axis, we change our x value. So a second image, because this is the second one we did, flip the sign of x, 4, -3. Y stays the same. B image second, flip the sign of x, 4, comma, keep y the same. C, second image, flip the sign of x, 1, comma, keep y the same. And D, image 2, flip the sign of x, and keep y the same. So now we're flipping in the y, because here's the y-axis. Our D's and C's will now become to the, now go to the left side, so there's still going to be 1 away. 1, negative 1. Yep, that's what I got for C right here, too. Okay, D is going to be 1, negative 3. Yep, that's what I got over here. Oh, this is D. For D, still going to be 3 away. 1, 2, 3. B, second image. A, second image. Oops, too many A's here. A, second image. There we go. Are the images congruent, meaning equal? Yes, they are equal because they are the same shape and the same size. Great. Let's go to those on your owns. Okay, for these on your owns, you don't have to graph this. You can use our cheat, okay? And it's not really a cheat because it's the property of this, the property, okay? Also, for 3 and 4, you don't have to graph it unless you need to. You can use the property that we know, okay? And then number 5, will the E look the same? Here's what you should have gotten. Okay. Go ahead and answer that essential question and take that checkpoint. I hope you guys are having a good day. Let me know how you're doing. Bye, guys.